good evening to my fellow professor. Today, me and my teammate will be presenting in about the debugging process for part one, uh, part one B, and so part one C programs, full detail debugging. And my name is Edin Mawat, and you call me Iz.
Hello, my name is Anika, and you guys can call me Anika, and I'm gonna start the presentation regarding to this code. So let's start from part B, which is this one, and this line includes the first line of this code include irvine32.inc includes the library which provides useful macros and procedures like dump-reds and exit that we will later use in the program. Let's come to the data segment here. Here, four 32-bit variables are declared in memory. The first one, val1, is initialized to hexadecimal 10000H, val2 to 40000H, val3 to 2000H. Final val1 is uninitialized and will store in the final result here. So let's come with this segment, code segment start, dot code main
Procedure.
PO procedure. Yes, this begins the main procedure. The CPU will start executing instructions from here. First instruction. This moves the value of val1 10000H into the EAX register. At this point, EAX is equal to 10000H. And second instruction is add EAX val2. Now we add val1 to 4000H to EAX. So EAX is equal to 1000H plus 4000H is equal to 5000H. The third instruction, sub EAX val3, sorry. Then we subtract val3 2000H from EAX. So EAX is equal to 5000H minus 2000H is equal to 300H. Then we can come to the store result here. The store result here, and the MOV final val EAX. This stores the result from EAX into final val. Now final val is 30000H. And if we come to the output, debug output, this calls the dump-reds procedure from irvine32. It shows the values of all general purpose registers in the output window, which helps us to confirm our operation were correct. We can explain with the windows we have to include, which is watch, autos, memory, registers, and disassembly. So to explain the debug and assembly program that performs arithmetic operations using 32-bit unsigned integers. And we can manually track variables values like val1 and EX by watch, and auto shows recently used variable and values, and memory, which shows the display raw memory content. Registers, it shows the CPU registrations, EAX, EVX, etc. And disassembly shows the low-level machine instructions.
Okay, and that is all for the part B program. Now moving on to part C. Okay, you may begin, Anika.
So in this part 3, the objective here is to perform arithmetic operations using 8-bit and 16-bit unsigned integers in x86 assembly. So if we see through the code here, 16-bit calculation using AX, we can see the first code is MOVAX val W1, add AX val W2, sub AX val W3, and MOV final val WAX. It results 1000H plus 400H minus 200H is equal to 300H. And if we come to the second part of it, as in like 8-bit calculation using AH, we could see MOVAH val B1, add AH val B2, sub AH val B3, MOV final val B AH. It results 10H plus 40 minus 20H is equal to 30H. The registers dumped is called dumpreds after each block shows changes in AX and AH.
Okay, so this is basically how the part C works, and as you can see, based on the values here, we can see line by line where the values are updating from the value 1 to the end, where in the final one, it will end with 3000H. As it subtracts, add, and finally stores, as you can see it in the final result, it shows that it is 3000H. And so on with the second one, where it starts with 1000H. Then finally moving on after adding and subtracting, and finally storing it, it will end up with 3000H also. And that is all for our explanation for the debugging process for both the Part B and Part C programs. That is all from us, and thank you.
Thank you so much.